Hey folks, welcome to my channel number pen. So there we have the problem on the screen. If integral of f dashed of x times e to the power x square times dx equals x minus 1 times e to the power x square plus c, then find f of x. So it's not a straightforward integration problem. We have been given the answer for a specific integral and we've been asked to find f of x, and I noticed that f dashed of x is a part of the integral, right? So this problem I had posted it as a quiz under the post section of my channel number pen, and I thought this video we will spend a few minutes trying to understand how to go about solving this problem. This is a very interesting problem. It goes back to testing all of us on the basics of integral calculus, right? Now, before I go about solving the problem, I want you folks to remember one thing, right? Now, all these problems we are trying to solve y, right? And what is my y? My y is nothing but integral of dy by dx times dx, right? That's what it means. So this is my y, and I hope you folks are with me. And this is why I mentioned that we will have to go back to the basics of integral calculus to try and solve this problem without much of a hassle, right? Now, you look at this, I'm just drawing a parallel to what we have been given, right? What we have been given is f dashed of x times e to the power x square dx. And let me highlight that in yellow. And if I draw a parallel to y, which is integral of dy by dx times dx, right? So now if I treat my y as the given expression, which is nothing but your integral of f dashed of x times e to the power x square dx, then what is my dy by dx? So let's write that down first. That's my y, and if I draw a parallel to what I've written in my earlier line, which is integral of dy by dx times dx, then I can conclude that my f dashed of x times e to the power x square is my dy by dx, right? We have our dy by dx, and if you take a look at the question once again, we already have our y, right? What is our y? My y is nothing but x minus 1 times e to the power x square plus c. Let me highlight that in a different color, say green, right? So I have my dy by dx in terms of f dashed of x. Now I have my y, right, which has already been given to me in the question itself. So let me pick out the expression highlighted in green. So that's my y. Now, if I differentiate on either side, right, I get my dy by dx. But when I do it to the expression on the RHS, which is highlighted in green, then I get an expression which is devoid of f of x or f dashed of x, right? So from that, if I equate it to the expression highlighted in yellow, then I'll be able to solve for f dashed of x and then my f of x, right? So let's do the differentiation on the right hand side. So what I get is x minus 1 times my d by dx of e to the power x square is nothing but I apply the product rule, and I hope you folks are able to recollect what we did under differential calculus. So this is my step 1, and my step 2 is I go and differentiate x minus 1, which is nothing but a 1, and then I retain the other function in the product, which is my e to the power x square, right? And then I differentiate my c, which is a constant, which is nothing but a 0. So what I have here is e to the power x square times, I know that I can pull out my e to the power x square as a common factor. I open my bracket, I get a 1 plus 2x square minus 2x, right? So this is what I get for my dy by dx. And I also know that my dy by dx is equal to, I'm picking out the expression highlighted in yellow. I'll retain the colors so that you're able to track what I'm doing. My dy by dx is nothing but f dash of x into e to the power x square. Now, if I equate it to what I just now worked out, which is also my dy by dx, then what do I get? I get my f dash of x times e to the power x square equals e to the power x square times 1 plus 2x square minus 2x, right? So now I notice that e to the power x square is common. I can cancel out that, and what am I left with? I'm left with my f dash of x, right? So my f dash of x is equal to 1 plus 2x square minus 2x, right? And when my f dash of x equals 1 plus 2x square minus 2x, I know that figuring out what my f of x is not too difficult, right? Why is that? Because my f of x, again, let me write it down. We'll again go back to the basics of integral calculus. How can I represent my f of x using f dash of x, right? My f of x is nothing but integral of f dash of x times dx, right? So what happens is, if I want to arrive at my f of x from f dash of x, all I need to do is integrate f dash of x with respect to x, right? So let's do that. It's not too difficult for us. We have a simple polynomial expression. So there we have our f of x. Now solving this is not too difficult. I apply the sum rule of integral so I can break it down further, and allow me to skip that interim step, because by now you guys are quite familiar with how to go about solving these problems. So my f of x is going to be x plus, then I have integral of 2x squared times dx, which is nothing but a 2 times x cubed by 3. And then I come to my third part, I have a minus of 2x dx, which becomes a minus of 2x squared by 2, which means I'll be left with an x squared, right? And then I have my constant c, right? So my f of x is nothing but, let me rearrange it with respect to the order of the polynomials. So my answer to this problem is 2x cubed by 3 minus x squared plus x plus c, right? Let me highlight my final answer in pink. So there we are. I hope you found this content useful. Please do subscribe to my channel and support. Thank you.